Good morning, students. This is the session 15 from the playlist of laws of motion, and the topic is Pulley Block System on an inclined plane. So, for this session, I have drawn one figure here in which two blocks A and B are connected together by an inextensible string, and they are passing, and this string is passing over a frictionless pulley as shown in this figure. Here I have assumed that this block A of mass m1 is moving up this inclined plane as indicated by this arrow. That is, this block is moving in this direction, and when this block A will move in this direction, then this block B will move in the downward direction. So here the angle of inclination of this plane with the horizontal is theta, and this is a frictionless surface. Inclined plane is frictionless. This is the assumption which I have taken for this question. And now here we have to find the common acceleration of these two blocks. We have to find the value of A. Now the first important thing, first important point, the first important point is that this block A of mass m1 will move in the in this upward direction only when the tension in the string is more than the component of the weight which is acting along this plane in the direction as indicated by this arrow. See, this block m1 is lying on an inclined plane, but its weight will be acting vertically downward. So here I have already so this is the weight is equal to m1 into g, where g is the acceleration due to gravity. Now since this plane is inclined with the horizontal at an angle of theta, therefore if this angle is theta, then this angle, that is the angle made by this vertical and the normal to the plane will also be equal to theta. Now the weight of this body will be acting vertically downward as indicated by this arrow. The normal reaction will be acting perpendicular to the inclined plane. So I have already indicated the direction of this normal. This end is the this is the normal reaction which is acting on this body, and its direction is always perpendicular to the surface on which it is kept. So the normal reaction will be acting perpendicular to this inclined plane, and since this angle is theta, therefore the component of the weight which will be supporting or which will be balancing this normal reaction will be equal to m1g cos theta, and the another component of this weight, that is m1g sin theta, will be acting parallel to this inclined plane in the direction as shown by this arrow. Okay, so now this block will move in the upward direction only when the tension in the string is greater than the component of the weight which is acting in the opposite direction along the inclined plane, which is equal to m1g sin theta. Second point, important point, which every one of you has to remember, is that tension always acts away from the body. So this is the body. So the tension will always, it is acting away away from the body, means the direction of this tension, this will be as indicated by this arrow. So this body A of mass m1 will move along this inclined plane in the upward direction only when the tension in the string is greater than the weight, the component of the weight along the inclined plane which is acting in the backward direction. So this is equal, that component is equal to m1g sine theta. So the net force on this block A will be equal to T minus m1 g sine theta. And as per the Newton's second law, this net force will generate the acceleration in this body, which will be given by m1 into A. So this is the first equation which I have got, that is T minus m1g sine theta will be equal to m1 into A, where A is the common acceleration of these two blocks which are connected by this inextensible string, and this string is passing through a frictionless pulley. And this inclined plane is also considered to be frictionless. Now let us come to the second block, that is the block B. So the mass of this block B is m2. Now since this block B will move in the downward direction only when the weight of this block is more than the tension in the string. So the net force on B will be equal to m2g minus T, and this net force will generate this acceleration A. So this will be equal to m2a. So I have got these two equations. Let us say this is equation number 1 and this is equation number 2. So from these two equations, what I will be doing is, if I simply add the equation adding 1 and 2, if I add both these equations adding equations 1 and 2, we get, if I add both these two equations, what will happen? This t and this t will get cancelled out, and finally I will be getting m2g minus m1g sine theta. This is equal to m1a plus m2a. So this will be, a will be common, and I can write it as m1 plus m2. So finally, I am getting this equation, that is m2g minus m1g sine theta is equal to a m1 plus m2, or a, that is the common acceleration, will be equal to, here g is common, so I will be taking g as common, and I will be getting as m2 minus m1 sine theta divided by m1 plus m2. So the common acceleration of this of these two blocks, that is when this block is moving downward, and when this block is moving downward, so it means that this block m1, this block A will be moving in the upward direction. When the block B is moving in the downward direction, then the block A will be moving in the upward direction. So, but both these blocks will be moving with a common acceleration, and the value of that common acceleration is equal to g. G is the common, M2 minus M1 sin theta divided by M1 plus M2. So in this question, the most important thing which you have to remember is that the weight will be acting downward. It will be acting vertically downward, and so you have to resolve this weight into two components. One is the horizontal component and one is the vertical component. This the component along this inclined plane will be acting in the opposite direction of this tension, and this block A will move in this upward direction only when the tension is more than this component, than this force, which is the component of this weight along this inclined plane. So the net force, the net force which is acting on this block A will be generating the common acceleration, and so based on this concept I was able to derive this equation number 1. And secondly, this block, if this block is moving in this upward direction, then this block will be moving in the downward direction, and this will happen only when this weight of this block B is more than the tension in the string, and tension always acts away from the body. So M2G minus T, this is the net force acting on this block B, and this will be equal to M2A. So based on these two equations, we were able to derive the common acceleration, and which is equal to G in bracket M2 minus M1 sin theta divided by M1 plus M2. So thank you very much for joining this session. And now in the next session, we will be coming up with a couple of questions based on the Pulley block systems. So till then, have a nice day. Bye.